Everyone, oh there we go. Hey everyone, welcome to a new video. This one is about AI systems, and I'm going to be introducing the concept of AI. And this first part is just doing a simple AI. We'll then evolve this AI into an optimized version, a class version, and then even pathfinding using the pathfinding service. And we're going to optimize that even further by using global tables that will manage all AIs at once. So, for now, we're just going to be introducing the single NPC idea. So what I mean by that is every NPC has one script, and then using that one script, we can make the enemy track us, or they do something pretty much. And so to start off, we're just going to, make a normal script. This is going to be the AI handler. And essentially for this AI now, I want it to track any nearby players, just moving towards them, and I want them to attack the player if they are within the attack range. Otherwise, I want them to patrol if they're not actually tracking anyone. So we've got three different things. We want them to patrol if no player is nearby. I want them to seek players if they are nearby, and attack players if they are close enough. So that's the three goals of this. So let's start with creating some functions that can help us achieve this. So firstly, when we want this AI to move, we want it to wait until the AI has reached where it's trying to move to. So if we use move to finished, the event under the humanoid, that sometimes does not work properly. I think we should probably go through that and have a look first, and then I can introduce it later when we optimize. So that's another note, now that I've thunk about it, that's another note for a different video where we optimize the move to. So for here, let's just do the normal AI loop. So let's do while true do. I'm going to have pass it 0.1, so that is the update interval of the AI. And what we are going to need is to check if there is a player nearby. So we need a function, local function, find nearest player. And I'm going to do that from this position. And let's do local target character, target distance. So let's have these two values returned. So we'll be returned a character instance or a model. And we'll have a distance value, which we can use to check whether or not we are seeking the player or if we're attacking them. Because if the distance is close enough, we can attack them. So let's go through and loop through all players. So this is going to be a players AI, where it just tracks and finds players. So for player, I usually call player local player. Get players do if local player.character, then so actually in this case, instead of nesting it like this and continuing in here, I'm going to do if not local player, then continue. And then so that's saying if there is no character, just continue on to the next loop iteration. And then I can just do local humanoid equals local player.character find first child, which is a humanoid. So we're going to try find a humanoid in the character. If that humanoid's health is larger than 0, then we can do this check. So, actually we also want the distance. So we'll do local distance equals position minus local player.character.primary part. Actually in this case we'll just do get pivot.position. So get pivot, it doesn't depend on the primary part. If we have a look at this NPC here, and we get the move tool, it depends on this little point here. So if I go in edit pivot, we can move this point around to where we want. So that makes things a little bit easier for some of you. So I'll use that pivot point there. So the distance is the difference in position dot magnitude. So that's the distance from the position. Yeah, find nearest player position. So we're going to look for the closest player to this position. And we need some variables. We need local attack distance. Let's do 5 local tracking distance equals 20. So this tracking distance is the minimum distance required, or I should say the maximum distance allowed to track a player that is near them. So here we can say if humanoid health is larger than 0 and distance is smaller than tracking distance, so if they are within range, if there is a target character already, so if there is already a target character, then we want to see if our distance is smaller than the tracking distance that already exists. Else, we want to set the character to this one. And we want to set the target distance to our distance. And then if our distance is smaller than target distance, so if our distance for this player is smaller than the closest one that we've already searched, then we want to change it so it's this one. This one's closer, so we want it to be the one that we want to target. And then down here, we're just going to return character target distance. So that's a fairly big loop. You can look through it again or rewatch from this point, but that's a pretty standard algorithm that a lot of even free model AI use. So now that we've got that, let's do local closest player distance equals find nearest player. We want the AI's humanoid root part position. So let's do local NPC equals script.parent local primary part NPC dot primary part. So the primary part in this case is the humanoid root part. And we also want the humanoid, which is NPC wait for child humanoid. We'll do that beforehand. Actually, I might change it, so let's do humanoid root part, humanoid root part. Let's do it that way, just to make sure that it actually exists. So here we'll do humanoid root part dot position. Yep. So that will give us the closest player that's within range. So if I go and print this, we jump in game here. Let me actually just save this. AI tutorial. So if we save this and play, there we go. So I'm within range and I'm at a distance of 10. I can get closer and closer. There we go. And if I get out of range, it does not find me anymore because I'm out of the range. And I can just get there. And then let's say I play with more than one person. So let me start up this local server. It should track whoever is closest to us, essentially. Or closest to the NPC, essentially. So, oh, okay, the server viewport broke. That's nice. I can't actually, here's the output. So, right now, player 1 is closer. So that's this one here. So I am player 1. However, if I stand here, and then go on this one, and I get closer than player 1, it becomes player 2. So it's essentially just looking at whoever's closer out of the two of us. And then for however many people there are in the game, it will do the same thing. So that is something we can actually optimize, but we'll do that later. Because there's several ways we can optimize that. Alright, let's jump back in the script. So now that we have that, we can do if distance is smaller than attack distance, then... So if they are within attack distance, else if... Actually, we should probably do... If closest player, then... If closest player, else... So essentially we want to do this here. So this actually is always going to be true. so we don't actually have to worry about that one. But essentially, we want this here. Oh, forgot that one. So this one is patrol. No nearby players. Seek out closest player. So actually, this should be closest character. And this one is attack character. Like that. So this is saying, okay, if there is a close character and the distance smaller than attack distance, then we want to attack it. Otherwise, if there is a closest character, they are within tracking range, so we want to track them out. So seek them out. And then if there is no closest character, that means there's no nearby players and we can just patrol. So patrol is you have a spawn location and then you go around the spawn location randomly, essentially. So what I need to do up here is get the spawn location position. Or actually, I'll just do spawn position equals humanoid root part.position. And that's all we need to do. And then what we can do is create a new function here called attack character. We'll do character. Yep. So attack character. So this is a NPC function. This is not a NPC function. So that's important to remember. This one doesn't use any variables of the NPC. This one will use variables of the NPC. So in our case, checking our health and checking our distance. And then also the attack damage. Local attack damage. Let's do 10. Local attack interval equals, let's do every 3 seconds. And we'll have last attack tick equals 0. So essentially this is the last tick where we attacked, the interval between attacks, attack damage, attacking range, and this is tracking range. Yep. So we'll have attack character there, and we'll also have local function patrol area. So this actually had to be target character. This one is patrol area. And then we want to seek player. So seek character, target character. So we'll have those three. So actually we can just straight up call these. If we do closest character, seek character, and patrol area. That should be plenty. So what I'm going to do here is actually just comment that printout, and we can start implementing these. So first I'm going to do the patrol area. So what we can do here is, let's, instead of using math.random, let's use something that's more random, which is called random.new. So that's going to create a new pseudo random generator, and essentially we can do pseudo random number generator next integer, and we can ask it to give us a number between minimum and maximum. So if I say -5, 5, it's going to be a number, so an integer, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. It's going to be one of those that it gives us. If we use next number, it's going to be between -5 and 5, but it's going to include decimal places. And that is going to be very messy for us. We don't want that. And if I have a look here and show you it, you can see that it's very decimal-like. But we just want a integer, which makes it a lot nicer to work with, especially when debugging. Actually, I don't even know if you can see that. But yeah, it's giving us an integer, which is a lot nicer to work with. So what this will do is create a random number for us. So we'll have x and z. We don't want to increase anything on the y, because there's no point in doing that. The AI is on the ground. So x and z is what we want to randomly add to our spawn location. So we'll call this a random offset location, which is the spawn position plus a vector3.new x0z. We don't want to increase anything on the y-axis, but we want to randomly increase on the x and z axes. So the AI walks in actually almost a circle now, pretty much. It won't. So how I know it's going to walk in a circle is that if I count 5 studs this way, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Actually, I need one more so we can see the 5th stud. And then I rotate it around. So essentially it forms a circle. Actually, in that case, would it be a square? It would be a square, but close enough. If you want circle randomness, then use math.sign here. But I don't want to worry about that. But yeah, essentially we've got the random offset, and then we want to move to that position. So we'll do humanoid move to. So actually, let's have a function here. Local function move to position. Let's do humanoid move to position. So this is an NPC function. And then humanoid.move to finished wait. So this is like the connect function, but it will yield the thread until it finishes. So now that we've got that, let's call that one there. And that's going to essentially move it there. And then we can simplify this here by putting those random number generators in there. Like that. So now we've got the patrol function. And then also, actually, at the end of this, let's wait one. No, let's have something else do that. So, like how we've got it here, we've got a last attack interval. Let's also have a last patrol tick. The last tick where we patrolled. And then let's have a local patrol interval. And let's have this as 2. The interval between patrolling the area. So this will be our interval between when we update and move to a different position in our patrol area. So if I do if tick minus last patrol tick is larger than patrol interval, then so if the time difference between the last time we patrolled is larger than our patrol interval, we want to reset the timer back to 0, and then we want to patrol the area. And then we're going to do the same thing for the attack. If tick minus last attack tick is larger than attack interval, then last attack tick equals tick, and we want to target that character. Oh, we want to attack that character. Find first child, which is a humanoid. So instead of using task.wait, we're using this tick method here. And then if humanoid and humanoid.health is larger than 0, then I'll remember that we added humanoid.health is larger than 0 here, so we don't track anyone that's died. And then we want to take damage, the attack damage. And that's essentially it. So since we only target players, we don't have to worry about this attacking anything else. And that should be the attack and the patrol done. So now if I run this, so I'm not going to spawn in the character, we can see that NPC is going to start patrolling around. Now we need to increase this radius a little bit, so let's make a variable for that. Local patrol distance equals 10. Patrol distance from spawn position. Let's increase that. Now let's run that. So there we go. Now it's going to start patrolling the area, which is nifty. So now that we've got that one, we can move on to seeking characters. Actually, let's also check the attack character. So if I walk up here, it's going to try seek me, but it can't. But if I get close enough, you can see it's attacking me every attack interval, which is what we actually want. So that's working correctly, which is sweet. And what we can do now is also add prints, so we know what's happening. So let's add a print right here called attack. Let's call this one new patrol spot. And this one is going to be seek, but seek is constantly updating, so it doesn't matter. So here what we'll do is, let's move to the target character.primary part.position for now. Actually, you know what I should probably do is, let's get the distance between the primary part position and my position. So humanoid root part.position minus that target character position. So actually, let's do target position because we'll need to move to it. So we'll move to that target position, and this magnitude is, the distance is the magnitude of the delta distance. So what we'll say is humanoid move to target position. Instead of doing this, we're going to use task.wait distance divided by 4. So this is essentially saying to us, okay, every time we use MoveTo, we want to yield the main thread until a time has passed where it's distance divided by 4. So that means if we're really far from the AI, or really far from the player, it's only going to last a quarter of that distance that we're aware. So if I'm over here, let's say that's 10 studs. This AI is going to yield for 2.5 seconds, approaching this before it updates again and checks where it needs to go. And then the closer and closer they get, the faster and faster it updates, because that means we want to check if we want to attack. So right here we've got new patrol spot. Let's see. Okay, let's have a look again. So we need a print. So let's do print seek. Let's actually put these on the outside. Patrol, seek, and attack. And actually what we can also do here is say if distance is smaller than attack distance, then we just want to straight up call the attack on that character. So we're patrolling there, we're seeking there, and then we're attacking, which is what we want. So that seek was because I spawned really high up, and it doesn't look like... I think this is what I need to do. I need to do local delta distance, or delta position is these two. And then I want to say if delta position dot y is larger than, let's say, 8, then continue. So that's essentially, if they are higher than us, we'll just ignore them altogether, because there's no point in trying to track them. There we go. So it's going to seek. And actually it looks like it's something else. So let's have a look. So when we seek, we're going to move to this distance divided by 4. So let's print that. Three seconds. Okay, that's a little bit too long. What if we do divide by 8? And that's quicker, but it's not quick enough. So what I'm actually going to end up doing is just deleting all of these together and just doing like task.wait 0.1 manually. I think that's probably going to work a lot better than trying to calculate it from the distance. Yeah, that's heaps better. So now it's actually going to follow us. If I stop, it's going to attack. And it's doing the attack interval and all of that. And actually, I'm going to make that up. I'm going to make the main loop update faster, and I'm going to make this one a little bit faster. So we're going to seek it, and then it's going to attack us. So you can see that's jittering a little bit. That's because it's updating so much. And I forgot the second argument for MoveTo. So if we have a look at MoveTo here, it gives a location, but we also want to give it the terrain. Since the terrain is a good way to, oh, what was it? So the walk to point is calculated from the offset of this, I believe. The base part to set the humanoid walk to part. I don't know, I forgot what it does, but it essentially does actually help it when you use terrain there or any base part. So I'm going to put terrain there, and that should help with the jittery. And also the jittery is because we're updating so quickly. So what I'm going to do is actually put that back to 0.1. So now if we have a look, it's still jittery. And it's just because it's updating so much. But yeah, now we've got an NPC that follows us. And it can't attack us when we're in its head. So since our attack range is 5, we can't actually attack it when it's on the head. So we'll just do that there. We can remove the Y component if we really want to. But we've fixed it now. If I stand up here, I'm still getting attacked. And yeah, so now we've got a working NPC here. And what I can do also is play an animation if I want. So what I'm going to do is quickly pull an animation out of my animations here. Hopefully I've got something I can use. Oh, that's animator. Let's do this attack anim. What's this one look like? Oh, can I not look at the Roblox website for it? That's annoying. I can't actually view the unless it's this button. And then can I go back to details? Sweet. Okay, I can view it. Well, that's a right kick, I guess. Actually, good left punch. Let's not look at that one. I could try that one. So if I put that in here. Now let's load that attack animation. Local attack animation track equals humanoid. Wait for child animator load animation. Script attack anim. So in the humanoid we want to put an animator. And so this attack track we want to put inside here. So if attack animation track, then we want to play it. And that's essentially what we do. There we go. And then if we really want, we can delay the attack. So we'll have 2 here. Let's do local delay equals 0. So local attack delay is 0. We can do equals animation track dot length divide by 2. So only halfway through will we actually attack it. And then we can do pass dot delay attack delay function attack it. Also, the reason why I put this in a task.delay rather than putting it here with a task.wait is that it will yield the thread and we won't be updating as quickly. So by putting it in here, we're still updating quick enough for the attack interval, which is what I want. So now if we try that, it should attack us halfway through the animation. Oh yeah, it actually needs to be, when you do length minus quarter of that. So that's going to be 3/4 of the track finished before it attacks us. So we have a look again. That's pretty close. I'm going to leave it at that. But you can see our AI is working correctly. And next time we're going to optimize this a little bit. Because we've got a problem where if I put a base part here, oh wait, that's why. Okay, I use normal humanoid move through there, that's why. But yeah, if I put a base part here, base part here, so that's blocking where it can walk. What we're going to notice is if it cannot reach the point like this, it will endlessly wait because we are using humanoid MoveTo finished. What we need to actually do is include a what do you call them again? I forgot. We need to include a, like, it auto cancels the MoveTo pretty much. So after a certain time period, it will just auto cancel the MoveTo and it will just progress with the AI logic. Which I don't know why I forgot it. Let me see what it's called. It is called a timeout. That's right. So we want a timeout for its MoveTo. So that way, after a certain amount of time, instead of waiting endlessly using this, it will just continue on from that point. And implementing it looks like this. So this is the non-optimized version, however. But if I just open Notepad++ here, this is what the MoveTo wait function looks like. So essentially it's, you give it a humanoid, a root part, a position, and it will yield the thread. So that's down here, it will yield the thread until one of these two finish. And one of these two will set the success value to true or false, which is returned. So you can say if moved to wait, then it successfully moved to the position. Otherwise, this one here will return true. So that's if it gets in the distance before this timeout happens. But that's some logic we'll look at next time. There is another version of this which looks like this, which is essentially the optimized version of it. And this uses an array of MoveTo data and then has one loop managing all of them. So instead of doing 2 threads plus the thread for the AI to check if they are moving to, or if they've finished moving to a point, then rather than that, I have this one here which uses one yield here, and it just adds one table into this one thread. So it's essentially creating a lot less threads. Like 2, was this 2? Yeah, actually, yeah, so it's creating two of these less, and everything else is pretty much the same. So it's a big improvement, especially when you've got a lot of AI. But we'll implement these later, which just looks like copying and pasting these in here and changing that MoveTo function there. Which actually I should just do now. Let me just do that now. So if we go in here, so we have our default timeout duration. So this is the default timeout for the MoveTo. We'll have our variables up here. So we've got whether or not the MoveTo succeeded, and we've got this bindable which is used to yield the thread. So this will yield thread until either one of these two things finish. So until this task.delay finishes or this task.spawn finishes. And only once one of those finish, then it will return success. This if success is equal to nil, so that is to check whether or not one of these have already finished by the time the code reaches here. I've had that happen before, so this is just a double check. And yeah, essentially this is like everything here. So we want a new timeout. So after our timeout period, we're going to set success to false, and we're going to fire that bindable. So that way it continues on and returns false. And then this one here is just going to check the distance between our root part and the target position which we're moving to. If that distance is smaller than 3, it will end the loop and return success equals true. If the humanoid.health reaches 0, it will just return true, but our main loop will cancel. Actually, I should probably do that. Humanoid.health is larger than 0. Let's put that in there. So here, actually, I want to do that. Yeah, that's what I fixed in the second one. I think I realized it. So right here, I do, if the timeout has been reached or the character dies, we return false here for the success value. For this one, I don't do that, so we'll just add that there. So success equals humanoid.health is larger than 0. And then here we have the MoveTo, so it, in case it stops moving at some point, so that's also another thing that can happen. It will just stop moving out of the blue. So this keeps constantly updating the MoveTo. We'll wait 0.1 seconds, we'll check the distance. If the distance is still larger than 3, then we'll do it again. But yeah, that's essentially that. Then we have yield the main thread until either one of these finish with a success value. And then we want to return that success value. So if we have a look at this MoveTo where we call it, we want humanoid root part position. So let's do MoveTo humanoid root part and the target position. Now also notice that I give it the humanoid and I give it the humanoid root part. So this is not a NPC function, it's a shared function between all NPCs. And then also here, we want to put random offset. And yeah, that's essentially it. So now we have a smart MoveTo. So it will check the position and it will also have a timeout to see whether or not we've actually reached a point. So there we go, it was stuck, but immediately updated off the timeout. So if we have a look at it again, seeking, it's not going to yield forever, so it's going to start patrolling. And if I get close enough, it will start seeking. And it will call seeking again. Because of the timeout, it will cancel its current thing and continue on like that. So that MoveTo has definitely helped improve the AI. Maybe not the smartness, but it has improved the feel of the AI and how it works. Because now the AI actually updates even if it's stuck, which can help. And if we add pathfinding to this, that's going to be even better. So that's what we'll probably do next time. Yeah, so next time we'll add the pathfinding, and next time we'll also add an optimization for this, which is essentially this one here. Which I'm just gonna add it now. I'm sick of not adding it. So if I add that now, so I'll walk through it again. So this one should actually be in a module, but we won't talk about that. Actually, no, yeah, I'm gonna add it to a module. So, the reason why I'm adding it to a module is so that that one table we have here is shared between all AI scripts. And that's important because if we don't share it between all AI scripts, then we're unneedingly creating this loop that loops through all AI, because only one AI will be using it under their scripts. So by doing it like this in a module script, it's shared between everything that requires it. AI MoveTo. So we'll just call it AI MoveTo for the moment. and I'm just going to return the function for this. So essentially, whatever requires this module, it will get the MoveTo wait function, which takes in the humanoid root part and position. So now if I come up here, instead of having this here, what I have is actually up here. Let's just swap these around. What I have is local MoveTo function equals require game get service replicate storage wait for child AI MoveTo, and then every time I call MoveTo, I want to just put MoveTo function. So now it's calling that function here, and I don't know why it's doing that, but it's okay, I guess. But yeah, 1, 2, 3, 4, 5, 6. I don't know why that's saying it's a bindable event. Let's actually just set these to values so we know. So if I look at here now, it's saying, okay, give me a humanoid, give me a base part, and give me a vector 3. And then we'll return a boolean. So if I hover over this now, we should see a boolean on the end, and that will be local successfully moved to, or success moved to. And that's just going to tell us whether or not we succeeded in moving there. So actually we can print that and see what it does. So if I do that now, did I not delete? No, I did delete. Good. So if we have a look here, we've got patrol. And it should output false because it couldn't reach it. Oh, did I... Oh, I need to index plus equals 1. Like that. So I forgot to increment the index or go to the next AI. So patrol 86. So it's definitely the MoveTo function not working here. Let's have a look. MoveTo weights. We want to add all that data in there. If 6 is nil, then wait for the bindable event. Return 6. So let's do print data. That's what I'm missing. Smaller or equal to the number of MoveTo weight. Now if we try that again, there we go. So here it says patrol true, so it reached it. Patrol 22 times true, patrol true. So seek here, it returned false because it couldn't reach me because of the block. But here you can see that it's reaching its patrol positions. So this one is getting stuck, so it's going to return false because it cannot reach it in time. There we go. So return false because it couldn't reach it. So that can be very useful if you are doing some specific scenarios where you might want to attack something if it can get close enough. So that's what you can use this MoveTo for. So for example, let me do if success MoveTo and that distance is more than attack distance, then I can start attacking. Attack character, target character. I can do something like that. So if we successfully move to that position and they're within attack range, we can attack them directly. But I don't want that here, so I'm not going to do that. But yeah, you can do stuff like that. The reason why I don't want that is so that... Actually, we don't even need this anymore either. Sweet. Yeah, I'll just get rid of the prints. But yeah, we've improved the AI quite a bit. We've got animations playing for the attack. We've got a MoveTo function, which is highly optimized for lots of NPCs. And we need to improve the attack stuff, but we can do that later. And yeah, hopefully you've learnt a bit. Hopefully you can use some of these even. And if we have a look at the seek here. It's definitely working, which is sweet. So yeah, hopefully you've learned something and helped. You can play around with the values to see how you can get it better. Like attack distance, you probably decrease. You could probably decrease actually the speed a little bit so you can run away. Stuff like that. But yeah, we need to change this next time into a class, and then we can have one loop, like we've done for this AI move to, handle all of the classes rather than having a wild to do made for every AI there is. So that's our next goal, and our another next goal is also to make this a lot better. Well, we've already done it now, so it actually doesn't matter, but yeah. And then we want to improve this find nearest player also. We'll use quad trees for that, which is going to be great. And I think you'll enjoy that. So, I shall see you in the next video where we improve these. Yeah, yeet.